Hello everyone, in this video I'm going to show us what solution is with examples of solution, problems and concentration. Solution is a system in which one or more substances are homogeneously mixed or dissolved in another. For us to have a solution, there must be solid and solvent. So in other words, solid and solvent forms solution. Solid is a component that is dissolved and it is always present in the least amount. Solvent is a dissolving agent and is present in the most abundant in this component. When a substance, which is a solid, dissolves in another solvent, it is said to be soluble. So, if the substance does not dissolve, it is said to be insoluble. For most solids dissolved in liquid, solubility increases with temperature. However, for most gases dissolved in liquid, solubility decreases as the temperature increases. Concentrations are the qualitative description of amount of solid in solution. We have various concentration terms or units. Molarity is one of them, and molarity is the amount of solid in moles, right, per liter of solution. We use the capital letter M to represent molarity. Molarity can be calculated from grams of solid or by converting it to moles. For us to use the solid in molarity, we have to convert to moles. For example, what is the concentration in molarity of a 200 ml solution with 5 grams of sodium hydroxide? The first thing we need to know is that this is the solid and it is given to us in grams. So we need to convert the grams, 5 grams of sodium hydroxide to mole. So we're going to say that 1 mole of sodium hydroxide from the periodic table we have 22.99 grams plus 15.99 grams of oxygen plus 1.008 grams of hydrogen. When we add all this together, it gives us 39.692 grams of sodium hydroxide. So we get this from periodic table, sodium hydroxide. So for us to convert it to grams, this is our given. We are given 5 grams, so it becomes 5 grams of sodium hydroxide times 1 mole of sodium hydroxide times over 39.692 grams of sodium hydroxide. So, and this gives us 0.126 moles of sodium hydroxide. Now, the next thing is we're going to convert our 200 ml to liter. So we know that 1000 ml equals 1 liter. So our 200 ml is gonna be, this is our given, 200 ml is our given, it's gonna give us 0.2 liter. So because molarity is given as moles of solid per liter of solution, our moles of solid is 0.126 mole of sodium hydroxide, and our liter is 0.2 liter. So when we use our calculator, it's going to give us 0.63 molar. Alright, another problem says to prepare 100 ml of 2 molar sodium hydroxide, how many grams do you need to weigh out? So as usual, we know that our molarity is the moles of solid per liter of solution. So what does this 2 molar means? It means that we have 2 equals to moles of solid, moles of our sodium hydroxide over liter of solution. So that gives us 2 equals to moles of sodium hydroxide over our liter of solution, which is 100 ml, is going to be 0.1 liter. So our moles of sodium hydroxide is going to be 2 times 0.1 liter, which is going to give us 0.2 moles. Now, from the previous example, we know that 1 mole of sodium hydroxide from periodic table is 39.692 grams. So we convert, we find the gram equivalent of 0.2 moles. So our given becomes 0.2 moles of sodium hydroxide times, using our relationship, so 39.692 grams of sodium hydroxide over 1 mole of sodium hydroxide. So if you plug this into our calculator, it's going to give us 7.94 grams of sodium hydroxide. So that is what we need to weigh out, 7.94 grams of sodium hydroxide. Another terms of concentration is mass percent. This is the mass of solid divided by the total mass of solution. Mass of solid divided by the mass of solution multiplied by 100. So we write it as this expression. So let's solve a problem here. What is the mass percent of sodium hydroxide in solution that is made by dissolving 8 grams of sodium hydroxide in 50 grams of water? So we need to write out what we have here. So our solid is 8 grams of sodium hydroxide, right, which is this, and our solution, our solvent here is water, and it is 50 grams of water. Based on our explanation for solid and solvent, we say solid is usually present in the least amount. This is 8, and this is present in most amount, that is our solvent. We know that solution is solid plus solvent. Solid plus solvent. So it's going to be 8 grams plus 50 grams, which is going to give us 58 grams of solution. So we have 58 grams of solution. Now to find the mass percent of the solution, the mass percent, we know that mass percent is the grams of solute per grams of solution. Our grams of solute is still 8 grams of sodium, 8 grams of sodium hydroxide, and our solution is 58 grams of solution multiplied by 100. So when we divide this, when we divide and multiply by 100, it gives us 13.8%. Right. The next concentration terms we look at is mass volume percent. This is the mass of solute in grams divided by the total volume of solution in mils. So we can write this expression this way. So example, what is the volume of 2% salt solution which contains 10 grams of a salt? So we need to ask ourselves, what does this mean? That is the mass volume percent for our substance. So we know that our mass volume percent, like we have written before, is grams of solute per mils of solution. So this is going to be 2 over 100. The grams of solute is 10, because we have 10 grams of salt. 10 grams of salt. Divide by the volume, which is going to be mil of solution. So we are looking for the volume, which is the mil in this case. So we rearrange our equation. Mil of solution is going to be 100 times 10 over 2, and that is going to give us 500 mil. Right. So we want to look at dilution. Concentration of a solution can be altered by adding solvent. This process is called dilution. When we add more solvent, we have what we call dilution. So in this process, the moles of solute stay the same as the solution becomes less concentrated. If you add twice the volume of solvent into it, the concentration is reduced by half. So the new concentration can be determined from this relationship. M1V1 equals M2V2. So let's take a look at this problem. How would you dilute 2 molar solution so that you have 100 mils of 0.5 molar solution? Right. We want to bring these 2 molar to 0.5, so we use this expression M1V1 equals M2V2. So in this case, our M1 is 2 molar, and our V2 V1, our V1 is what we don't know, right? Becomes our X. So our M2 is 0.5 and the V2 is 100 mil. So we rearrange this equation and it's going to give us V1 to be equal to M2 V2 over M1. And we plug our values into that, it gives us 0.5 times 100 divided by 2. We plug that into our calculator it gives us 25 mil. Right. Mil. Right. This goes away. And we need the volume that we need, which is V1, is 25 mils. So what is the molarity of solution prepared by diluting 65 mils of 0.95 molar nitric acid solution to a final volume of 135 by adding water? So we want to find the new concentration. We already have our initial volume and the initial concentration to be M1 to be 0.95, V1 to be 65 mils, and our V2 is 135. We're looking for M2, right? So rearranging this equation, our M2 should give us something that looks like this. When we rearrange our equation, M1 V1 over V2. So that gives us 65 times 0.95 over 135, and that gives us 0.46 molar. Right. So that is the new concentration that we have. I hope this helps. Thanks for watching.